What's up, guys? On the road again. Had a question pop up yesterday, a real aggressive holding tank where they're neutralizing groundwater, and wanted to share with you guys a couple things to consider here, and really what's going on with that system is the whole groundwater storage tank. It's more just an open top tank, think a big pond, and what they're doing is they are neutralizing all their recovered water as well as spills and everything throughout the facility. And so the water itself is not the issue, as I suspect most of you probably guessed, right? Water is loosely not much of a concern, especially with a lot of the systems that we deal with our epoxies. They're all great in water. Where the issue is coming from with them is in their neutralization, because they're using sulfuric acid. I think they said 93% or 98%, one of the two, very high concentration, and they're using caustic at a 50% concentration. Now, neither of those unto themselves are overly worrisome. They can be difficult, but they're not overly worrisome. But the issue with the neutralization comes from what's called thermal shock, or in this case, the reaction when they're mixing this acid or this caustic in is generating a lot of heat, okay? And so the coating itself is not necessarily failing chemically, but thermally, when that acid hits the water, there's a big exotherm or generation giving off of heat. Sorry, I don't mean to call anybody stupid for not knowing what exotherm is or exothermic reaction, just laying it out there. But when that acid hits the water, there is a reaction, there's a lot of heat, especially when you're neutralizing. You get heat, you're putting in more acid, you're generating more heat on top of the heat, and that will ramp up. And so one of the big things, they have said, hey, we put in a coating, everything chemically looked good, and it failed very quickly. And from what I gathered, it was a thin film system, which isn't necessarily a bad thing. Again, you guys know my position on thick film, thin film. It all just depends on the application. It doesn't mean it was a bad system, doesn't mean it was a bad coating, doesn't mean it was even a bad installation. But when we're dealing with a lot of that heat, thin film systems are not geared to take heat in the same way that a thicker system is. And so with something like this, assuming we use the same resin, let's just go with, hey, the system you guys put in that failed is a great system for you, but let's beef it up a little bit, right? Let's make it a little more robust. And one of the things that I do is I will actually add in sand. And for something like this, I will take that from a thin film system, say 20, 30, 40 mils, and I'll make it maybe a half inch, maybe an inch, maybe 2 inches. And I'm waiting on their full spec sheet to really delve into what that's going to be. But the purpose of that is twofold. One, with a thicker system, what we can do is just from pure heat exchange, just general, math there, more material can take more heat. Not necessarily more specific heat, meaning, per quarter inch, it can still only take the same amount, but we have more material there. Ergo, if 40 mils could take 100 joules of energy, then 160 mils could take 400 joules of energy, notwithstanding that the top might fail in the intern. Now, what I do is I will add in some sort of functional filler, in this case sand, and what it will allow us to do is, one, as opposed to doing a thick system that's all resin, which can get very expensive from an investment standpoint. It's not that it's not good, it's just, that's a ton of resin. What I'll do is I'll use sand, and one is it allows us to build bulk or thickness with an inexpensive material, right? Sand is not expensive relative to the resins that we most commonly implement. And two, sand is very good for absorbing heat. And I'll give you an example. the resin we use specifically for our polymer concretes, not the functional resins that we'll add sand to, but specifically for our functional concretes, our polymer concretes. Those resins, unfilled, if I mixed them, would have about a 20, maybe a 25-minute pot life, right? They're very, very fast resins. When we add sand, typically to the tune of 50 to 60 pounds per gallon, that pot life goes to about 2 hours, okay? And the reason being is it's absorbing all that heat as the epoxy is reacting, right? Epoxies generate heat, and it's really slowing it down. Now, where that applies here is once we put that system in, if the resin can take the chemicals, the epoxy, or excuse me, the sand is going to absorb a lot of that heat. So we talked about where that neutralization is happening when they're adding in the acid, the caustic, and right where it's hitting that water, where you get a lot of reaction, you get a lot of heat generated from it, the sand, and in this blend, you know, the sand's going to be probably upwards of 60 to 70% of that formulation. The sand is going to be able to absorb all that heat and very quickly, thereby protecting the resin. In the flip, because it's absorbing the heat, the resin can protect the sand chemically, although the sand in this case is relatively inert anyways. The resin is now able to protect that system all the way through. And so again, with something like this, the sand is giving us, one, the ability to protect the resin from a heat capacity standpoint, absorbing heat and mitigate that, because that heat is only on introduction to the system. Once it's mixed in, there's really not all that much heat. It's more a chemical function now that the epoxy is more than geared to handle. And then two, because we need a thicker system, it allows us to build very quickly with something that is inexpensive. Okay, and so if I do, let's say, throwing out random numbers here, no square footage, let's say I did a 40 mil system with epoxy and all my material for the given system was $100,000. If I wanted to go to an inch, well, if, you know, 40 mils was $100,000, then multiplying up loosely, an inch of pure resin would be $1 million, okay? But if I do it with sand, I go from $100,000 to $110,000, $120,000 maybe, you know, because that sand is inexpensive and allows us to build to that inch with ease, with control, and give us all the properties that we just talked about. So, as always, if you guys have any questions on this, any concerns, want to share a story, anything, drop a comment down in the description. Everything I'm giving you here is based on experience I've had, projects I'm involved in, you know, more for you guys to help in your day-to-day throughout everything that you guys are trying to do. If you want to work with me, you know, drop a comment. But again, this is for you guys so that whoever you're working with, another supplier, another distributor, another manufacturer, you have some good questions for them if you have a real critical application and you want to make sure you nail it on the first go. So appreciate you guys. Take care. Godspeed.